Hi there, my name is Rakibul Hassan. Today I have something really special to show to you, a project which is focused on DevOps. Now I call this project a mega project because it focuses on all the pipeline and operational side. Let us see one by one. Now these are the tools that I have been using to completely deploy my project. So for the cloud service, I have been using AWS, and for the security code check, I have been using SonarQube, and for the monitoring, I have been using Grafana, and to create the infrastructure, I have used Terraform, and to push the code, my code lives in the GitHub, and I create the entire pipeline using the Jenkins. Now all the container, since I have been using Docker, all the container needs to be managed, so that is doing using Kubernetes, and I use Trevi to check those containers and many more. Let us see one by one. Now this is the actual workflow. First, developer will push the code into the GitHub, and Jenkins pulls that code and start a job called CI job, which is continuous integration jobs. Now from there we'll start the dependency check, which is done by OWAS. What it does, it actually checks the dependency for our project. For example, if I use .NET, it will check the nuggets and verify it, and from there we can push that into Trivy to check further, and in the SonarQube to check the quality. If everything is done and Docker image has been created and pushed to the Docker hub, that CI job is completely done. Now when the CI job is done, CD job has been triggered. What it does, it takes the code from the GitHub, it takes the code image from the Docker registry, and using the Argo CD to replace the image in the Kubernetes service. After that, I have used Monitor and Grafana to monitor what is happening in my project. And that's basically a quick architectural overview. Let us go to see step by step how it's actually flowing. Okay, so first I have created the master node on the AWS using Terraform. Since Terraform is infrastructure as a code, so we can create any infrastructure like EC2 machine, S3 bucket, anything like that. So we need a master node to control everything. That is basically our master node. Now inside the master node, we have to first install the Docker, enable the Docker and start the Docker. Then we have to install the Jenkins for CI/CD pipelines, and we can access them using their IP and the respective port number. Now after successfully installing Docker and Jenkins, as you can see, I have the Docker and the Jenkins both are running on my master node. Now since I have Jenkins and I can access it via my node IP and the port, I'm going to that Jenkins and install necessary plugins. Now next, once the Docker and the Jenkins installation has been successfully completed, let's install the Kubernetes cluster, which I am using. EKS stands for Elastic Kubernetes Service. As you can see, the cluster itself is called Mega. Now since I have created the cluster on the master node. Now I need a worker node because master is not going to handle all our pods. So I create another node called worker node. We can create hundred of thousands of node, no worries about that. Now as you can see, it calls mega worker node right below the master node, because master node will be able to run our application, manage all the run our application and everything. Now since the Kubernetes cluster has been set, now let's install the Sonar Cube, which is a container. Actually I pulled a image and run the Sonar Cube container, which is currently running on my master node. And remember one thing, master node is the brain of all thing. It actually controls all the worker node and everything. Now since I have to connect the Sonar Cube with the Jenkins, I need a webhook from the Sonar Cube. Here I am creating a webhook from the Sonar Cube to connect it with the Jenkins so that Jenkins can trigger the Sonar Cube. Now let's install the Trivy, which will be responsible to scan and check vulnerability of our Docker image, containers, Kubernetes, etc. And it will be running on our master node. Now this is one of the critical part, and this is one of the extraordinary part of my project, which is Jenkins shared library. Now think of it like there are many jobs like setting Kubernetes, checking some of the things repeatedly. So why not made a separation of concern, which will be some specific reusable function that is present inside my Jenkins shared library, which is on the GitHub actually in a repository, and I will connect it with Jenkins so that Jenkins can use it and reuse that function. So another day another project has been arrived, so we don't have to write everything from the scratch. We can use those function and reuse them. This is what the shared library repository look like, and as you can see there are some common functionality, reusable functionality. We just call them in our Jenkins pipeline and use them. Now since shared library presented in GitHub repository, of course I need to connect it with Jenkins so that Jenkins knows that there is a shared library I can refer to. As you can see, I am setting the shared library inside the Jenkins systems. Now here comes the amazing part, which is Argo CD, and this is the part I love the most. Inside the masternode Kubernetes cluster, I have installed the Argo CD. As you can see, all the pods, services, servers of the Argo CD that are present inside the Kubernetes cluster, and all the services as well. After successfully installation, I can access it just like Jenkins or SonarCube, any other thing. I can access it using masternode IP and the respective port number. So let's I have set it up the Argo CD. Now Argo CD is a separate, since it's a separate thing, we need to connect the GitHub repository with Argo CD. That's why I have created a repository and connect my GitHub repository with it so that Argo CD knows which project I need to scan and deploy. Now, since I have created the repository and I know Argo CD knows what repository to looks, what repository for look. Now let's create a app which will basically use the Kubernetes cluster and the GitHub repository and connect them. And where connect them, we can create a app. So what happened in future, I have another separate application, I can create another app. That's make pretty much easier. As you can see in this slide, I have connected the repository and I have connected the Kubernetes cluster, so it knows both repository and Kubernetes cluster. And one other thing, there is a path called Kubernetes. So inside my GitHub repository there is a directory called Kubernetes, and inside that directory I have created all the YML file which is basically responsible for creating services, namespace, deployment on all the pod for that particular project. And as you can see, all the backend and front end and every YML file to create the pods that I have been telling in the previous slide. Now, after everything is done, let's focus on creating jobs, which is CI pipeline in the Jenkins. Now, since I have installed the plugins and tools for DevOps, SonarQube, Tree, Docker, and everything GitHub on the Jenkins, let us see how the flow will work. So what this CI job does, it does some step-by-step jobs. It checks the code from the GitHub, pulls the code, and after pulling the code, whoops, dependency check, start scanning. It checks for packages, nuggets, npm. It mostly checks that common vulnerability issues are there. After whoops is done, we move on to the SonarQube. So SonarQube takes much longer time. It actually checks code quality, bad practice, and duplicate code and any other stuff. That when that job is also done, Tree scan the file, checks the container, Docker image, and look for vulnerabilities. That's done. After that, if every scanning is done, it's the Git SecOps security is saying your job is done, everything is good. Let's focus on building Docker image. So first build the application and create the Docker image, and after creating the Docker image, if everything is successful, push to the Docker Hub registry. And after complete CI part is done, let's trigger the CD job, which is Mega Project CD. Now for the CI part, as you can see, these are the step. It's checking one by one GitHub code, Tree, ops, and everything for the CI jobs in the Jenkins. As you can see, all the stages has been successfully completed, and this is just a console output for the CI jobs. Now after CI job is done, there is CD job. It actually triggers automatically. Now we have the image pushed to the Docker Hub. So we pull the image from the Docker Hub, update the image tag, what version it is currently. It could be any number of version. And when the image is there, the Kubernetes, what it does, we need to set the image inside the Kubernetes. So it actually does by Argo CD. What it does, it actually detects the change and it enters the directory Kubernetes and update the image in the YML file using the latest image. After that, after updating the image inside the cluster, it actually restart the image and all the ports has been restored. If everything is done, now the application is live on the browser. As you can see, these are the CD pipeline stages mentioned: work, GitHub code checkup, Docker image pull, and complete deployment with Argo CD. As you can see, all the stages for the CD job also been completed. Now we can see both jobs simultaneously, part by part, and the mega project CD and mega project CI. So let's say after all the pipeline has been triggered and all or triggering in the Argo CD, we can see live what is happening, how my ports health is currently in, is it sync or not, any issue occurred. The Argo CD continuously monitors that. As you can see, it's processing. Now inside the Argo CD we have this beautiful diagram which basically shows the cluster and all the ports, all the services, everything are there, so we can easily monitor what's going wrong and immediately fix the issue, because that's what DevOps do. Now, since our project has been successfully deployed and live running in the production or any other user, let's create the monitoring, which is one of the essential part of the DevOps, using Prometheus and Grafana. So as you can see, inside the Elastic Kubernetes cluster, I have created the Prometheus and the Grafana as well, as you can see, and all the pods and services related to Grafana and Prometheus. And also each time, every tools after installation, we need to whitelist or set the inbound rules for that port. So let's say I have some ports running inside the cluster. So cluster is exposing the port using node port. Node port means I can access it from the outside. So to go it from the out, so people can access it from the outside, we need to set the inbound rule that does the user can make in incoming request. It's like that. So since we need to access the Prometheus and Grafana both from the outside, so we need to set the inbound rules for that specific port to access them. As you can see, all the Prometheus and Grafana ports are successfully installed and set it up, all the services. After that, we can access the beautiful Grafana. So let's take a look how the internal works for that. So what it does, actually there is node exporter is a service which is monitors the system, the CPU and each and everything. And there is another thing which is C advisor. What it does, it actually monitors and store information about the current container activity and each of the stuff. And then there comes the Prometheus. Prometheus grab those data from node exporter and C advisor and store it inside the Prometheus database, which is time series. Now Prometheus has all the data. Now Grafana basically pokes the Prometheus to tell it, give me the information so that I can create a beautiful dashboard. So as you can see, there is a Grafana dashboard, and after setting up, and this is the part where I connect the Prometheus with Grafana and test the connection using the URL. That URL is basically Prometheus site's URL. After testing connection, it shows successfully tested, and we can import a dashboard which is looks like this, and it actually monitors the systems live going on, and there are multiple monitoring options. We can see one by one. We can see that it actual job is node exporter, and it's running on master IP, and it's monitoring and the Kubernetes cluster, and there's more. And thank you so much. I have put a lot of effort to create all the end-to-end production ready system so that it works smoothly. If you have any query, please do reach out to me, and here's my email and the LinkedIn. You can reach out to me. Thank you for your time. Thank you.